Good morning. Today I'm going to talk to you an interesting subject, that is uranium enrichment. So what is uranium enrichment and how it is done, how they develop this enriched uranium into a nuclear bomb. So I'm going to talk to you about that today. So before that, let us talk about atoms. In this universe, everything is made of matter, and matters are made of elements like hydrogen, helium, sodium, potassium. All these are elements, and combination of these elements will give you those matters. And every element is made of atoms, and atoms of a particular element will have an atomic structure, and all the atoms on that particular element will have the same type of structure. The oxygen, for example, oxygen will have 8 protons, 8 neutrons and 8 electrons. So this is the atomic structure of an oxygen. So all the atoms in the oxygen will have same set of atomic structure. Now let us look at the uranium now. Uranium has 92 protons, 146 neutrons and 92 electrons. This is the uranium atomic structure. It's called 238, U238. That means the number of protons plus number of neutrons. Then in the same uranium we'll have another atomic structure that got same number of protons and same number of electrons, but neutrons are 143, little bit lighter than the 238. So this one we call 235, uranium 235. Other one is uranium 238. The difference between this one is a mass, atomic mass. One has a little bit heavier, other one is lighter. So this is how the uranium 235 and 238 is found. We call this isotope. This now let us get back to uranium enrichment. To make a nuclear bomb or to power nuclear reactor or to power the submarine, you need uranium 235 because that's the only one that you can split, right? We call fission. So it's called fission atom. It can be split. So, but in the world you find abundant uranium. You can find in Australia, Russia, Ukraine, Canada, everywhere you can find uranium. But 99.3% of the uranium found in this world are U238. So that's the only one that is found. Only 235 is only 0.7%. That's a very little. So what they need is now they have to separate the 238 from 235 to extract 235. So what they do is first they mine the uranium, everything together, 235 and 238 together. It is called uranium ore, O-R-E. Uranium ore is mined. Then this uranium ore is converted into yellow cake. It becomes like a paste or powder. It's called yellow cake. Then from yellow cake, it will be converted into gaseous state. It's called hexafluoride, UF6, hexafluoride, right? This gaseous state is used to separate 235 into 238, separate that one. So what they do is they use what you call centrifuge. Centrifuge is nothing but a tube, right? Strong tube that spins at a very high speed. So this tube, they put the hexafluoride inside. The hexafluoride will have a combination of 238 and 235. Now that spins at a very high speed, so the heavier particles will go to the edge of the cylinder while the lighter particles will remain in the center area. Now that lighter particles will be channeled to another centrifuge. There also you will have a little bit more 235 and less 238. That is an enrichment. You are increasing the 235. Then from that centrifuge, again the same system. It rotates. The heavier particle go to the sides and the lighter particle will be channeled to the next centrifuge. Like that, you keep on enriching. That means the number of 235, if you increase the number of 235, we call the percentage of enrichment. 1% enriched, 3% enriched, 5% enriched. And normally for you to have this power the submarines or nuclear reactors and all, you don't need to enrich very much. You can have it with 3%, 5% or 50% like that. Whereas if you want to make a nuclear bomb, that one we call weapon grade. To make a nuclear bomb, you need to enrich this uranium up to 90% or more than 90% to 100%. That means you will have more 235 and lesser 238, right? Once you enrich 100%, that means you are totally having 235. And this is what used for making a nuclear bomb. So how they make a nuclear bomb? Say you have a nucleus, right? This is the atom of a uranium 235. Inside this you have 92 protons and 143 neutrons. What they do is they will take another neutron and they bombard this one with 2200 meter per second speed. When that comes and hit inside, this neutron will go inside this, right, nucleus. When that goes inside, now the number of neutrons will be 144. So uranium 235 becomes U236. When that happens, this nucleus will be agitated because it got an additional neutron. So it becomes unstable and it will vibrate, right? It will vibrate and it will split, and that becomes 2 atoms that split into 2. When that split into 2, that additional neutrons inside will be about 2 to 3 neutrons will come out, right? Then surrounding area, the electrons will travel at a very high speed. They confine this blast into a ball. When they confine, and they will have a reflective material so that it hits and comes back again, hits and comes back again. When that comes back, it will go inside another one called hydrogen atom. The hydrogen atom and the combination with another atom, they want to make 2 positive atoms to combine. It's called fussion, F-U-S-S-I-O-N, fussion. To combine that, because both are positive atom, it will very hard. They'll try to repel. It won't join. It won't join. It will try to repel each other. But they will have to increase the temperature so that it become a plasma. The whole area, right, become plasma. Then it will get merged, right? This is what we call nuclear fusion. This goes in. When that happens, then again it will split. It will try to rebel. Then it again split. Fusion, fission, fusion, fission will happen again and again until this plasma, that whole thing becomes very highly concentrated energy. I'll try to blast. When that blast, it will become a nuclear bomb. So initially, those days they have only fission. Now they have fission and fusion together, make it a very strong nuclear bomb. To combine these two positive atoms, what they need is they have to have a temperature. They have to increase the temperature up to 150 million degrees centigrade. 150 million. Your sun core in the sun is only 15 million centigrade. Imagine the entire thing of fusion, fission, fission, until to blast, it will happen 60 billionth of a second. It will happen in 60 billionth of a second. Second is like this. And if you take the second and divide that by 60 billion, and that time frame, that's like micro, maybe seconds. In that time frame, only the entire thing will happen. Fusion, fission, then it will blast. When that happens, there is a high energy that dissipates and high temperature will be engulfed the area. When that happens, the high temperature, because the high temperature, it will try to rise up, right? The higher temperature will try to rise up on the atmosphere. When it goes up, it will suck everything within that range, about 1 kilometer or 10 kilometer, depends on the size of the bomb. It will suck in everything and burn and just try to go like a mushroom cloud. The difference between the conventional bomb, and the nuclear bomb, in the conventional bomb, you'll be thrown out. The blast will throw everything out. Whereas in nuclear bomb, it will suck you in with the high force and pressure, that everything suck you in and become a mushroom cloud. So it is very, very inhuman way of having a warfare. So that is why all these countries will have a nuclear doctrine. Nuclear doctrine means it is not every country will say, I will not fire first. I will. So they keep all these things in a separate location. Your warhead will be in a separate location. Your bombs are in a separate location, and the fuse, the triggering mechanism, that is another bomb, right? That normal explosive, and that also will be in a separate location. They call it fuse. So all these are separate location, and they bring it closer to each other. When there is a wartime, they say we are bringing the nuclear doctrine to the lowest level, and they bring it closer, but they won't fire, because if we fire that, if one country fires nuclear bomb, that means that the end of the whole world, because end of the mankind, end of the life in the world, because everybody will fire with each other. And there is like America got 5,000 nuclear warheads, and Russia got about 5,000. We don't know how much they got. Then India got about 179. Pakistan got, China got, all these fellows got nuclear, UK, France, all these fellows got nuclear warheads. And this will be the North Korea, and all will be a disaster for the entire world. Hope nobody fires, and make sure the human beings are happily living this world forever. Thank you.